Waiting for video.
We always learn later.
Okay, guys, let's get started for today. So here's our schedule. Here we are, week 13. Believe it or not, today I'm going to answer a couple questions. There's kind of generic questions, talk a little bit about case study 5, just a really little bit, and let you guys ask me more questions. And then I have a review of material that I'm going to talk about for the exam. Note here that I'm not going to do a Zoom Q&A on Thursday because I'll be out of town. But I'm happy to answer questions by email, and I will continue answering questions on the discussion forums. And I can set up individual meetings if so desired at some point, but I'm not going to be here on Thursday. Okay, let's see. So that brings me to, we have exam 2 next Tuesday at this time right here. And it is exactly the same format as exam 1, as I told you. There are 5 10-point questions and 10 5-point questions. Short answer, exactly the same format. So I put the discussion forum topic for that if you want to ask questions. And then as we go through the review of material, I will be happy to answer any question that I can. Grant is finishing the grading on case study 4 as we speak. I did an initial part. He and I met. We discussed it. I want to make one comment, though, about that with respect to case study 5. In case study 4, we really didn't grade the report very strictly. In other words, we asked you to report some statistics, and you did. And we asked you to describe your material blockage statistics, and most of you did. But there really wasn't any discussion of the results per se. It was just all, show us this, which you did. Case study 5 is quite a bit different because in case study 5, we asked you to actually do something, make recommendations, justify your recommendations based on the experimentation. So the actual write-up and the writing associated with the write-up will count much more than it did in the previous ones. It's more than just modeling and presenting us the results. Now you are making some recommendations and then justifying those using your experimental results. Yes, sir?
I want to understand what's the purpose of the recommendation in terms of, do we want to find the dispatching strategy that works best for most of the scenarios, or like a recommendation for every scenario?
Well, the recommendations that I actually make are about the changes in the model. So you can do, you can get this high-speed packaging line. It can have capacity 1 or capacity 2. You can hire another. You can get rid of one of the changeover operators. So you have a set of things that you can do. I'm looking for you to say, I think you should do this, and here's why.
Not in terms of dispatching also. And for
well, I mean, the initial part where I was just saying, show me these results, is really just so that we can get comfortable that your model works. So that's going to be similar to what we had in before. But in the recommendation, I'm looking for a lot more. Yeah.
I have a question related to
Ask away.
Now. So I understand this is a system, this is a company, and this is what we are suggesting to do for them.
Yep.
The scenarios is just how we validate why. Like, we show the statistics, and then we said, for this company, they should implement this because it's how we get the better.
Well, again, think about.
But thinking about all the scenarios.
You are working for a company.
Yeah.
They have this assembly line or this manufacturing system, and they're saying, hey, we're thinking about doing these 3 things. Should we do them? And if so, what and why?
Okay.
That's what you're trying to do.
It's not just for one scenario.
It's not for one scenario. It's for just saying we should do this, right? And ideally, you would have more data, but you don't. You only have 5 data sets. So, yeah. So you're making that recommendation. I bring this up again because the writing now becomes much more important in terms of justifying what you did. So be aware of that. And again, I'm happy to answer more questions if you have those. So let's see. I got a couple of questions that were things that I want to discuss primarily from the discussion forum. I didn't put them on a slide or anything, so I'll just talk briefly about them. The first one had to do with this material blockage metric. I think Madison posted this about does anyone have any better ideas? Because one of the things I also mentioned is that for case study 4, I didn't want you to share dashboards and all of that stuff between groups, but now you can. You're free to share material, to discuss how best to present things, and look for other ideas all you want. And so I think she initiated that. So I just wanted to talk about that for just a second. I really like the question. And so this is my case study for baseline model that I did. And the metric or the dashboard that I did for my metric is similar to what a lot of you guys did. A lot of people did something very similar. It's because it would be a natural thing to do, where you just take the constraint log, And so I have the constraint log where I just, have all of the constraint types, and if you select the material availability for this scenario, I don't remember which scenario I'm running here, but all of the material availability happens at kitting, and you look at these two basic numbers. Here's the number of blocks there were, and then here's that total number. And I think her question revolved around the fact that, we get this number, 57.1K, but is that really useful? Because what does that number actually mean? Right? And so again, it's a great question, because when you think about what we're trying to capture, it's material blockage, and material blockage is bad because you can't, you're not producing, right? And we certainly get a number, and if you reduce the blocking, that number will certainly go down, but it's really kind of a difficult number to attach meaning to. And so, for example, and this will get worse when we add schedules, right? When you add work schedules. So, for example, let's say that I have an order that finishes just before closing on Friday, and I don't have any of the boxes, right, that are available. So there's a material constraint right before closing on Friday, and supposed to have a delivery of boxes first thing Monday morning. Okay, so the net effect of that is that it's going to have no impact on that order, because I wouldn't do the order on Friday afternoon anyway, and the materials will be in stock on Monday. But yet in the material constraint log, you're going to see a really long blockage. If the blockage is measured from when the blockage started, which is close of business on Friday, to when the blockage ended, which is opening business on Monday. So that's a case where that number will be big, or relatively big, but it's meaningless. Right? In the real context, there really is no blockage there, right? So the question again revolves around, well, how else could we do this? And that's the part I don't know the answer. It's a great question. I don't know the best answer. I don't know how best to measure it, but the critical part is to understand why that's an interesting question. Because this is really simple to get this number, 57.1K. It's really simple to get this 581. But what you're looking for in this metric is something that's going to lead you to one solution or better. Right? So again, go back to the example that I gave where something's not there, finishes late Friday afternoon. Well, suppose I just move a material delivery so that the Monday morning material delivery arrives Friday at closing time. Then you have no blockage. Right? So you've gone from a really long blockage to no blockage, but the net effect on the order is 0. So does that really mean anything? Okay, and so trying to figure out, that's part of what we're trying to do with dashboards is trying to figure out how do I convey, and this metric in general, how do I convey information that we can use later on in decision-making context? Yeah?
One problem I had with that was that I could only use data from one log at a time, or one table at a time. Is there a way to bypass? Was that just me? Or
I don't know the answer to that. So I got asked that a couple of times, how you could do it, and I don't know whether you can or not. I suspect that there's a way, but I don't know.
I know that if I was in card 1, I could do one table, and card 2, I could do a different table, but then they don't really interact, so it doesn't filter.
They will interact sometimes. So for example, if you have multiple tables that use the exact same names, it tries to do filtering for you, but it's not perfect.
Yeah, not for tables that are referenced. Use tables that are referenced.
Yeah.
You might know.
Right. So when you said sometimes it'll try to match them up. There's a setting where when it says apply master filters, multiple master filters, next to it there's another button or something that says cross log referencing or whatever, and if you set that, and then the thing that you're filtering for has to be the same thing in both logs, so you can't say
It's in results.
I got to go to the planning part, not the planning part, the interactive part.
Cross data source filtering.
yes, but it has to be the same. It can't be
Oh, the name of the column should be the same. Just
the name of the column, but also it can't just be the same column name. But what's represented in that column has to be the same thing, referenced by whatever you're trying to filter for.
Yes, this right here.
Yes.
Oh.
Yeah, there's some stuff in there that to do that. Thank you. And if you look in the help again, it tries to help you, but it's kind of limited as to.
My main problem was that while I was trying to make the metric inside the dashboard, I could only see the material, the constraint logs. I couldn't see any other table.
Yeah.
So if I want to do a metric like that combines a lot of elements from different places, I would have to do it outside of the model.
Yeah.
And use that for my car. But then if I did that, I couldn't do filtering on it.
Yeah. I totally understand. I don't know the solution, but I totally understand.
Do you know if there's a way, so like I tried to do this at first and then gave up, but I kind of wanted to start a process the first time the material was blocked.
Yeah.
And start measuring time between that and the next arrival
With the
of
data
like
statistics.
materials. But I couldn't do any kind of, like, I looked for add-on processes that would trigger when that first material would be blocked, and I couldn't get anything to actually trigger.
Yeah, if you knew the material went to 0, you could trigger on it the crossing state with a monitor, but it's going to block sometimes when it's not at 0. Therein lies the problem. So I can't think of a direct way right now to say, okay, how do I know exactly when that first constraint happens?
Because I was trying to do it based on the bill of materials, and most of them was like, if it's less than 2, basically, it would block.
Yeah.
But like, I wasn't getting it till like.
Yeah, I don't know a way that you can say trigger a process to happen when a constraint is violated. I will give that some thought and see if you could do that somehow with the constraint element, but I don't know off the top of my head for an event to trigger on the constraint, because that's really what you're after. Is if you look at the constraint logic elements right here, my 2 constraint logic elements, is that I would like to trigger an event when that happens, and whether there's an internal event, I don't know the answer to that. So that brings me to the second sort of question I was going to give. I was just going to show a quick demo here. In the Q&A session last time, I mentioned that you can use output tables in dashboards also. And so someone asked me about that, and I couldn't answer the question that they asked, but I decided I would do just a really quick example and show this how this works and how you can use it. So I made a simple model where I just have an arrival that I limit to 10. I limit to 10 arrivals. They just go to the server. I haven't done anything, and then they depart. And I created this output table where I have arrival time, entity, and departure time. And arrival time and departure time are both reals, and entity is a string state. And so these are output tables because an output table is a table where every column is a state rather than a property, a state column. Right? And output tables have this property where you can add rows as the model runs. Okay, so that's what I have right here. And so what I do in this simple model, it doesn't really do anything. It just executes this add-on process when an entity is created. And the add-on process basically uses the add row step. And then it uses the assign, and it assigns the first 2 things. It assigns the arrival time, which is time now, and it assigns the model entity name, which is model entity.name. Okay, and then I have at the end, on entering state assignment, where I assign the departing time. Okay, and so I use the add row here when it arrives. Then we do some processing, and then I do the state assignment there. And so if you run the model, just run in fast forward mode. I only have 10 entities, and go look at my data. I have all of the data that I have there. Right, and so what makes this interesting, again, is that you can create output tables for whatever you want. I mean, so this one creates a row for every entity, but I mean, you could create rows based on anything that you want to create rows on, and you can record any kind of state information that's of interest to you for your dashboard, right? And what makes it powerful, if you notice in this one, is when I use the add row step, right? So when I use this add row step back here on the add-on process on the source, right? What that does is it creates a table row reference, and so the entity has a table row reference to that output table. Okay, so I can have as many entities in the system as I want, and they all know which row they reference. And so later on in the model, I mean, this is a really simple model, so there isn't much later on, but later on in the model where I write that departure time, every entity knows its row because of those set row steps, right? And so that can be really useful. And so you can have any arbitrary information that you'd like to have in the output table that you create. If you want something in a dashboard, you can create the table. Now,
Does it have to be related to the entity?
You can have it whatever you want. This one's related to entity, so I just add a row for each entity. But I could have that entity, add rows every step of its processing if I wanted, and the table would correspond to, not just the entity related, but entity and step related, right? So, When you don't have it related directly to an entity, you have to deal with the table row referencing, but really that's not that big of a deal because you can also search the table. Okay? Now what the question was about is how to get output statistics in the table. And I can't figure out how to do that because output statistics are recorded once you hit end at the end of the run. And after you've hit end, you can't execute an add-on process, right? So if you look in the model, if you look in the processes here, and you can select a process, there's an on-run ending process. And oops, I didn't have the model running. And so if I were to create an add-on-run ending process, right when the model ends, it's going to execute this process. And so if you keep manual statistics, that would be where you would write like rows of all that. So let's say that I had 10 different things that I just wanted to track at the end of a run. I could do it right there and then write all that information to an output table. But the internal, like getting resource or server one scheduled utilization, for example, I couldn't figure out how to access that object itself. And so if I wanted that, I would have to construct that expression myself.
Were you able to calculate or like make a dashboard or have you seen a dashboard that you felt like accurately calculates the scheduled utilization?
I did it.
Even the changeover operator?
Yeah.
Okay, I'll talk
Because
to
I
that.
included the capacity of the station. They did computer, like same as you explained us one time about the schedule utilization is whatever you utilize divided by whatever
divided by the
available.
available time.
The issue with the resource status low is like they are assuming that you have only one resource. So they are divided by the max span, but when you have two resources, that's 2 times the max span, that's it. So what you need to do is just to identify like the unit that you have scheduled, and that's it. I will share that with you.
So those are the 2 questions I got. And if you guys have other questions for me, I'm happy to answer them now or do the review and then, yeah.
Could we, would it be acceptable to make a discussion post or something where we could put all of our dashboards?
So you can upload the XML, right, to your comments, like in the discussion forum, right?
Hopefully. Yeah.
I mean, you can upload files. I know that. I mean, I'm assuming you can upload XML.
If it decides to work with you.
I'm happy to do that. And happy to have you guys upload them because, again, the objective here now shifts to, we're not trying to identify the best performance metrics. You're trying to use the model to make decisions. So I'm happy for you to share stuff like that. Yeah.
I have a question about the report.
Okay.
So I know we should report the verification process that we did. That verification must be about the new things that we are doing or the whole model?
The whole model.
Whole model?
Yeah. Because we didn't have a verification report on any of the other components of the model, which I entirely meant to do, but we didn't do it. So hopefully you guys were doing it all along the way because as you build every model, you should be verifying it. You should be verifying it every time you build a model, and you should have your notes from when you built case study 2 and case study 3 and case study 4. You should have all of that, and so now it's just formulating it or assimilating it all.
Of course. Oh, and I have a question about case study 5.
Okay.
So after finishing task 1, that is when we are gonna come up with like the best dispatching rules.
Okay.
In task 2, when we need to like decide which change the company should do,
If any.
should we use the dispatching rules that we said in the task
I'm the
1?
company. I'm thinking of doing these 3 things. I'm asking you and paying you a lot of money to tell me what I should do.
Okay.
That's the whole idea, is that you're telling me what I should be doing. Now, obviously, I want you to use the results that you have.
Okay.
And you know what my metrics are. I mean, I've said what I'm interested in is fill rate, and I'm interested in blockage, and I'm interested in utilization because that leads to decisions about...
If I have 2 options, it's gonna be different. The sequence
Sure.
is gonna be different than if I just have
Sure.
1. So
And since you don't
maybe
know
I need to use that
costs...
changes.
Yeah, but since you don't know costs, and the reason I told you that you don't know costs is because you can't just say, I like option A. You've got to say, I like option A because it's better than option B in this context. if I told you option A costs $50 and option B costs $25 and I gave you a profit for every order that shipped on time and all that, you just do a mathematical analysis. I don't want that. I want you to tell me why one is better than the other. So you have to analyze them all and then look at the relative benefits of one versus the other. Okay? Okay. Yeah.
My question is that I've been testing, I'm still on like C12 one right now, but I've been testing out different ones. And like, is there like a range? Because I've done like 30 different tests and gotten the same thing. Is there like a range on when like, okay, maybe we should just stick with this, or should I?
I'm not sure what you're asking. What do you mean by test?
Testing out the different dispatch rules.
I don't want you to do like 500 different combinations.
Okay, just kind of like whatever, like explain that we tested it on, this is the best thing that we got. Okay. I wasn't sure there's like one answer that you do.
There's not one answer. I don't want you to do hundreds and hundreds. I mean, you're just trying to get kind of a feel for what it tells you. And I mean, again, don't get caught up so much in the specific numbers because you can say, okay, I did this set of dispatching rules and it goes down by 10 minutes. That doesn't matter. That's an insignificant amount, right? Mathematically, you can say, I get a better number, but does it really matter? Okay, anything else for now? Yeah?
Is there any way you would consider moving the due date for case study 5?
I can't make it anything after the close of class.
Yeah.
It's the last day of class. I can't make it due during finals week. Sorry.
No, it's fine.
Maybe on Sunday then?
I can't do it after the last day of class.
I have a question, but it's more about the case study 4.
Okay.
So we compared with some of us, we compared our results, and we came up with something very weird
Okay.
that I don't know if you came.
Is this Grant what you told me about, Grant? Did you guys talk to Grant about that? Grant told me about some weird case where you guys all got a couple of numbers.
I've never talked to her, no.
Okay, well, yeah.
But it's the same thing.
Is it that two groups of students have different results?
No, now we have 3 different results.
Oh, and then there's me.
That's not something I can do. What Grant was talking about, that's not that I can just answer off the top of my head because I would need to.
Yeah, but just because we have a deterministic model, yeah? All the numbers that we're using, the time, the processing time, whatever it is, it's a fixed number.
Yeah.
But we are getting things like it's seconds of difference.
And there's something different. You have a deterministic model. You have identical models.
Because we follow the
This is
videos.
going to affect you. They should be identical.
Can I give my 50 cents on this? So, what I think happened, because I saw my model change behavior just by creating a new model. So, between the first change where we do earliest due date and die breaker by least setup time, and then we do the same, but the first one is priority on XYZ orders.
Yeah.
So, if our dispatching, when we start fresh, like nothing has happened, the first batch of orders come in the system, there is a decision that everything is a die.
Okay.
Everything is a die.
Okay.
So, if our EDD plus at least the first change we do, the first rule of dispatching, if it chooses the OEE orders, it's the same thing as having the priority first.
But it's because of the
It dispatches almost exactly the same. There's like 2 or 3 orders that change.
But it's because
So
of
one
the
results
quantity.
for the second, for the first dispatching will change and the second dispatching will change was exactly the same,
Yeah.
except for 2 or 3
It must
orders.
be the same
It must
at
be
the
the same,
beginning
yeah.
because of the
So what's the
quantity
question?
of the
I hear you.
order.
There was a time where I ran the model using Simio.
Yeah.
I don't know, I think I changed the randomness or something,
Okay.
and it didn't dispatch the OEE first. Like I had this happen once.
Yeah,
So
I
there is a
can't comment on
possibility
that.
that with the same model, you get different results because there is a tiebreaker rule there.
There are cases where you have
So they're both correct.
a minor difference that causes something like that. Because again, think about how an event calendar works. You've got hundreds of things that can happen at the exact same time. And so something is making a choice of which one of those things happen at the same time. And if any of that changes, then you're going to get a slightly different
We
result.
will try to figure out where a second of difference could came up because we have a deterministic model.
Yep.
And yeah, we noticed that of course if you're finished earlier in 1 second of difference, if you add it up in one moment, one order is gonna come to the transfer node first then another one, and then
Yep.
everything. Like the sequence is gonna change. We have sequence dependent changeover. Of course, we are gonna get different results. But like what was hard for me to understand is how in a deterministic model we could have a 1 second of difference.
It's
Once again, something changed.
like even with my
Something
undergrads,
changes.
they have a very simple model. I will check everything in that simple model, and I will not be able to find anything they did different than the person sitting next to them, but they like have different numbers, or like anything they did wrong. They'll do something slightly different, like very slightly, and it causes the numbers to be off completely. So it's just a weird thing.
But that's
I
probably.
mean, again, you have a whole bunch of, think of the
But
case where you have a whole bunch of things that happen at the
But yeah,
exact same simulation. Something has to decide which one goes first. And if you change that choice, it can make drastic differences, right?
Yeah.
In this case, it was in the whole plan.
Yeah.
Like the whole plan.
Yeah, because the
whole plan
sequence
changes.
changes,
One
and
decision,
then
one decision changes the whole plan.
That's why this class is
Anyway.
important.
Okay. Let me talk about some of the material that I pulled together. Feel free to ask questions along the way. We talked about this general notion of scheduling, and hopefully looking back at all of this, a lot more of this stuff, you're going to go, okay, yeah, now that makes sense. You know, we've seen Gantt charts all the time. We talk about this notion of scheduling. We're allocating resources over time. That's really what we're doing. And the easiest way to explain a schedule is to give this Gantt chart view where, in this case, we have our resources and then we have the jobs that are processed on those resources. So this notion of scheduling says I'm going to determine sequence and then I'm going to set the start and end times for operations. That when we talk about scheduling, that's what we're talking about doing. We have some terms and concepts, and now again, hopefully a lot of the stuff you're familiar with. We have this notion of jobs. You can also call them parts. In our recent models for Hobby Electronics, we were focused on orders. So we had orders were represented by entities. You can have people and so on. We have operations, and those operations require resources, and they have process time. They have precedence constraints, like our orders for module ABC go from kitting to kitting to assemble to finish to package to ship, right? So those precedence constraints are sequential there. We have ready time. So in our case, we have order arrival time. So that's equivalent in the scheduling context to be the time that job, or in our case, orders are ready to be scheduled. It's when they arrive. Due date, we have priorities, bill of materials, which specify raw materials and components. We have all of those things in our case related to orders. Resources can be things like machines, servers, workers, changeover operators in our model. All of these things are resources, and the idea is that the jobs need some units of capacity of that resource to have some processing. And so it's that competition for those units of capacity of the resource that we're doing scheduling, that we're implementing in scheduling. We have setups. We have sequence-independent setups and sequence-dependent setup. So sequence-independent setup, you incur every time, regardless of the sequence of processing of parts. Sequence-dependent setups are the time that required to set up a machine depends on the sequence of parts. So in our case, finish, for example, when I go from one color to another color, you know, it takes a different amount of time. So I might be going to red, and if I'm coming from blue, it takes one amount of time. If I'm coming from yellow, it takes a different amount of time. So even though I'm processing red, it takes a different amount of time. It depends on that sequence. We saw that. Secondary resources, we have tooling. We don't have any tooling in our case, but we do have operators. We have the changeover operator. So at both the finish station and assemble station, when we have to go through one of these sequence-dependent setups, then we need that secondary resource, an operator, to do the setup. Schedules, we talked about sequence versus schedule. So a sequence is just an ordering or a permutation. A schedule then attaches start and end times to those. We also said there's an infinite number of schedules for any given sequence because you can have forced idle time, right? With a sequence, forced idle time is meaningless because it doesn't change the permutation. For a schedule, it makes a big difference. Non-delay schedule, active schedules, we talked about regular measures of performance, all of those concepts we've talked about. We've talked a lot about dispatching rules and what they are and how they work. So I have a queue in front of a resource, and the dispatching rule basically says, how do I pick the next one? When the resource becomes available, how do I pick the next one? FIFO, LIFO, shortest processing time, longest processing time, earliest due date, critical ratio, and a whole lot more, sort of on a conceptual level. When we talk about dispatching, that's what we mean. We talked about schedule generation and this basic process, and leading up to the fact that when we talk about simulation-based scheduling, it's very similar to an implementation of schedule generation. And the whole idea of schedule generation says I have these sets of tasks. I have the set U of unscheduled tasks. I have a set P of precedence feasible tasks. So from my set that are unscheduled, I have a set that are precedence feasible. Then from that set that are precedence feasible, I take a set of what I will call schedulable. So one implementation of schedulable says anything that I can start right now. So if the machines are ready and the operators are ready and everything's ready, I'm going to pick that time and I'm going to take everything out of set P that can start at that time and put that in set S. And then I choose some set S and schedule and so on. And every time you schedule something, you go back and update these lists. So that's the general notion of schedule generation is I continue this process until I don't have any more tasks in U, right? And then I've generated or created my schedule. Talked about that's essentially what simulation does, right? So if you think about our model of Obby Electronics, I started out with all of these jobs, all of these orders, and all of the orders have a sequence of tasks. Well, a lot of those tasks aren't precedence feasible, right? So I'm just going to take the whole set the operations that can start, like kitting, and then I'm going to pick one, right? And that's essentially what we're doing in this schedule generation. And so in the class, when I demonstrated this, I showed this specific example, and we looked at the trace. And so by looking at the trace, you can see all of this stuff happening. You can see tasks being allocated. And so on. And the key here, that one of the reasons we want to use schedule generation or simulation-based scheduling in particular is it does something called actionable schedules. So it implements the detailed operations. And the example I gave is if you have setups. Right? So if we have setups in my schedule generation or in my scheduling methodology, I don't consider those setups, then the schedule that I've created is not actionable because I have to handle that setup. So it might not change the sequence, but it's going to change the times because of that, because of the setup. And so that's notion of non-actionable is the type of results that you get if you don't include all of the details. And the benefit of using discrete event simulation is we can make them arbitrarily detailed. So I can include anything that I would like to include, from setup, sequence-dependent setup, secondary resource requirements, tertiary resource requirements, any of that stuff I can incorporate into my model. And then by means of how discrete event simulation works, I'm going to generate a schedule that's feasible, that's actionable. Okay, and that's why we want to use the methodology. We went from dispatching to talk about the semio implementation of dispatching. In particular, two things. We have the static rules, ranking rules, and the dynamic rules, which are the dynamic selection rule. So we talked at length about this notion that a static ranking rule basically determines the sequence or determines the order of entities in a queue, whereas the dynamic selection rule determines the sequence that I'm going to select out of that queue. And so by default, if I don't have a dynamic selection rule, then I'm just going to use the queue ranking rule because it's going to take the next one. But I don't have to do that, right? And so if I have a dynamic selection rule, it goes through and recomputes every time there has to be a reallocation. Okay, and so that's computationally more expensive, but it also lets you change the priorities based on what, the time that the decision is going to be made. We talked about this notion of work centers, and the reason we wanted to talk about this notion of work centers, we said we're interested in dispatching, but here's the configuration that we have at the finished work center, right? And in order to implement this, so that what I want to have happen is I want entities to come to this transfer node and then be dispatched to the finish station that's available, right? And so in order to implement that to get the way we wanted so that it could go to the one that's going to be available soonest, is we set all of these input buffers to 0. So if all of the input buffers are 0, then the implications, the question I asked here is, what are the implications on this from a dispatching context? Right? So it doesn't really make any sense to have dispatching rules at the servers because there's never a queue in front of the servers, right? The queue is always at the transfer node. So the implications of this issue of having zero capacity buffers is that we want to implement the dispatching here. And in all of our models that we did, starting with case study 3, all of the dispatching rules were applied to the transfer nodes that led into the server-based objects. And that's why we defined the work centers to be a transfer node and a set of these server-based objects. And we did that even if there's only one, like we did for kitting and packaging. There's only one server, but we still use that transfer node notation so that we could use that sort of generic notion of routing to the transfer node, and then using that transfer node to be the gatekeeper where we apply the dispatching rules. Do you have a question? Okay. So we did that. Then we jumped in and talked about task sequences quite a bit. The idea of a task sequence is, it's a set of tasks where we can implement precedence. We can have conditional execution. Associated with each task, we have a process type. So we can either have a specific time, or we can call a process, or we can have a submodel, we can have a sequence-dependent changeover. We also have sets of resource requirements, material requirements, state assignments, and add-on process triggers associated with each task. And these tasks can be represented using a network representation, and it's extremely flexible. And so you can see in the S1 there, I just have 3 sequential tasks. In S3, I have a starting task, and then I have 2 tasks that can either be parallel or an option, right? And so this notion of conditional execution will let me say for server 3, if I have conditional execution, I can have the 2 that are in parallel, I can do either or if they're always executed, then I just have 2 tasks where there's no precedence relationship, so they can be happening simultaneously. And then we have this arbitrarily complex one here that includes aspects of parallelism and sequence, and if you add conditional execution, again, they're quite complex. And so regardless of what that task structure is, each task has these same things, that you have, the process type, resource requirements, material requirements, state assignments, and add-on process triggers. Okay, and so we use this quite extensively. In our model, we had this basic structure where we had a setup time, a process time, a finish time. And then in some of those, we wanted to go back in and add a second setup for the sequence-dependent setup. And in some of them, we wanted to then add that secondary packaging operation and so on. So we just augmented the standard task sequence that we did to include those. We talked about materials. They're elements used to represent consumable resources where I don't need to animate and I don't need to track entity-related states and properties and have logic and behavior and all of that kind of stuff. It's essentially just a counter. And then I can consume and produce. And so typically we consume for the bill of materials. So like in our Obby electronics, when an order goes to kitting, we're going to consume all the constituent materials. Right? So you have component A and 2 component Bs and 4 component Cs for one of them, right? And so in kitting, we're going to consume that. And so when you do a consume, it basically looks at those individual material elements and says, are they there? If so, reduce the number, right? So it's just reducing the counter number and letting those entities pass. Okay, and that happens in the constraint logic element, which we applied at the transfer node so that we wouldn't transfer to the server. So even though we could transfer them to the server and have the material constraint block there, we used the constraint logic element so that it would block at the transfer node so that it would let other entities that don't have that material constraint pass. But the same logic applies in that we are using that constraint based on just a specific number. Then we have inventory elements. We didn't use too much inventory elements, but essentially what an inventory element does is it attaches location information to a material. So from a model standpoint, a material is just a global number. If I have component A, I just have some number of them in my model. There's no location associated with them. If I use an inventory element, I can actually have that somewhere. So if we had used that, say, if we'd expanded our model to include, say, a warehouse, we might have component A's, 500 of them in the warehouse and 100 of them on the assembly line. Okay, and so the material constraint could be applied at the inventory level, and then you could do replenishment from the warehouse. We didn't do that in our model, but that would be an implementation where you would incorporate this notion of location associated with the material. We talked about this replenishment behavior, again, something that we didn't use. We didn't use the standard replenishment processes, but we talked about it quite a bit. And the basic idea is that I can use a policy, and in the Simio policy, it sets the parameters associated with the replenishment, and then you create an add-on process called the on-replenishment add-on process, and then that's where you actually implement. So you can think about implementing logic depending on what your model is, but eventually you're going to get down and have a produce step. And that produce step is what's going to actually produce or replenish the inventory. And the inventory replenishment policies can be applied at the material level, so kind of globally, also at the inventory level where you would apply those locally. Again, in our case study models, we didn't use this replenishment. We replenished, right? We just said we're going to schedule these deliveries, and then we'd use the produce step. So our replenishment was based on a schedule, not based on any particular replenishment policy. But we could have just as easily done it based on a replenishment policy. We could have said, when component A gets down to 100, order 500. And here's how you do that, right? Here's you order it from a supplier and you go through a delay lead time and that kind of stuff. And we could implement this structure. We didn't do it in our model, though. We then talked about this general implementation methodology where we go from a domain model to a conceptual model to an implementation plan to a Simio model. And hopefully, in a perfect world, you guys would have done this 5 times. Case study 1, case study 2, case study 3, case study 4, case study 5. I don't know if you did. My suspicion would be that you would not have, but I hope that you did. So the basic idea of the domain model, there's not much for us to do here in a domain model because when you talk about a domain model, you're really setting the scope and objectives for the overall model. And in a classroom environment, that's what I give to you, right? So the assignment that I give you, say for case study 5, is the result of a domain modeling exercise, right? So if you think of Obby Electronics being a real place, which it's not, I made it all up, but if it were a real place, the domain modeling exercise would be to produce that document that I give you. Okay, and so that's what the domain model is, scope and all of that. Then you take that and you create a conceptual model, and the conceptual model is a language-independent description of the model to be developed. So the way to think about a conceptual model is, I'm talking to someone who knows simulation, but they might not know Simio. Maybe they know Arena or AutoMod or ProModel or something else. So they understand the concept of simulation. And so the conceptual model is saying, I'm going to create the logic, the simulation logic for the model that I want to implement. Right? So when I say language independent, that's what I mean. Then we take that and do an implementation plan, and you're saying, okay, if I have this conceptual model that I'm going to implement, now how am I going to do that in Simio? Right? And that's how you map out the structure that you're going to do, and then of course you then create the Simio model. Okay, and far too many times what people do is they start out with a plan at the very top level, and then they jump down to the Simio model, open Simio and start coding. It's a bad strategy. You will always save time if you follow a process like this versus just jump in and start doing modeling. So we talked about dashboards quite a bit, especially near the end. It's a graphical user interface that provides, key performance metrics or KPIs that are relevant to a particular problem at hand. You guys have been doing this for the past couple of weeks. From a dashboard perspective, there are 2 different sources or 2 different types of sources of information. We have logs and we have data tables. Data tables include output tables like I showed earlier in class today, right? And so the logs, in order to have access to the log information, Simio tracks that for you, but you have to tell it. And we went through the process of adding logging information and so on. Okay, so you can build dashboards from logs, from tables, from combinations of those, and so on, and that's where we're extracting the information. We talked about the Simio ISA 95 templates, really what they were, that we are, on our way from our Obby Electronics, sort of the next step. If we had a case study 6, like if we were going to go another few weeks in the semester, our next task would be to let's jump to these templates. So we are on our way to using the templates with custom objects and the task sequences that we developed and the changeovers and kind of moving. If you notice from case study 2 to 3 to 4, we sort of moved more and more of the information into the tables so that we could generate the model from data and drive the model from data. That's really what our goal was, and that's really all subsumed in this ISA 95 template. And so there were these 2 different categories. We talked about the order-based routings and product-based routing. We just talked kind of casually about what that meant. But that basically For the product-based routing, it was similar to what we have, right? That we have that our routings are based on the module type, and the orders are for the products. Whereas an order-based routing is different, that you don't have specific products, but that the routing is custom for each order. And we have a set of custom objects. In particular, the kind of main object, if you want to think of it that way, is a SCED server. We called it AE server for Aubrey Electronics, but it's the same basic concept where we have a default set task sequence, and we have the secondary resources and the bill of materials and so on. These are all tied to the table structure. And one of the things that we didn't do in our model, but that is important, and that a lot of the kind of difficulty people have when they first start using the ISO 95 templates, is this understanding of what's going on with work in process, right? And so we assumed that we didn't have work in process in our models, that orders just arrived, and then we set the ending time to, when we finish the last order, right? But if we want to do things like weekly schedules and so on, then what's going to happen is we're going to have stuff that we're working on at the end of a scheduling period, right? And it's going to be halfway through processing, and we need to start the next week with that stuff in its current sequence. So I might have, 2 orders in the finish station and an order in packaging and, 5 orders in kitting all on Friday afternoon. Well, when I come in Monday morning, I need to pick up where I left off. And so that notion of work in process says, how do we do that? And so the ISO 95 template is set up specifically to allow that. So that through the data tables, you can tell it at the start of the scheduling period, here's the stuff that's already halfway through or some portion of the way through its sequence, and it's structured to accommodate that. And when I said half of the difficulty that people have when they first start using this is there's a whole lot of logic associated with that. Most of the logic is coded for you inside of the template, but if you want to understand what's going on, it gets to be a little complicated. And we talked about a couple of the expressions that we use to do the conditional execution here, and I showed those, and we saw those. So again, we didn't do this, but these are important concepts that are associated with that with the template. And then I mentioned that there is a scheduling discrete part production, which uses the ISO 95 product-based routing template. And if you look at this example, there's a PDF. It has all the CSV files, and you can basically, create a new model from template, read in all the CSV files, and you have the model. So there's no modeling that you do other than reading in those CSV files. And it kind of demonstrates this power of having data-generated modeling. As you read the CSV files in, it constructs the whole model for you. In real models, you're going to have to do some customization of that. But in this example, it just does it for you. So very useful to have a look at that. Talked about 2 general things that we didn't really have time to talk to get to, but were important, and it had to do with this notion of when we identified modules, when we identified our modules A, module B, and module C, we didn't really uniquely identify them in an order. So if you remember when we had in case study 3 and in case study 4, we had, say, module A, but we also had to know what color it was, right? So I have a module A red, a module A blue, a module A green, a module A yellow, module B red, blue, green, right? And so we had this issue where we had multiple characteristics to define the item. And so that violates something that's called APIC style, American Production Inventory Control Association Society, something like that. And their standard basically says you have to have a unique identifier. So I need to be able to uniquely identify things with the SKU. So what we called module A, we could implement that by saying module A blue, module A green, module A red, right? And so you just pin the information together so that I have this unique identifier. And having the unique identifier is really important when you're reading information in from an enterprise system. Okay, so for example, if you log on Amazon or something and buy, I'm going to buy a custom item that comes in a color, like I'm going to buy a piece of furniture that's blue or something like that. Behind the scenes, there is a SKU number that concatenates those things together. It doesn't always just strictly concatenate them, but these things are all uniquely identified. And we didn't do that in our model, but if we want to use APIC style, that's something that we would do. Implications of that are basic with our basic model. What it would change is that we would have a whole lot more routings and bills of material and so on, because when I look at widget or widget A for us, module A, widget A red, widget A green, widget A blue, right? Those are all different things, and so they all have to have their own routing, even though all of the routing is the same. Just the bill of materials when you get to paint is the only thing that differs, but you have a replication of all of that data. If I'm reading all the data in from an ERP system, it doesn't matter. That helps me actually, because I have a direct translation or a direct usage from the ERP system. If I'm doing that manually, it becomes more tedious, and if I'm doing it manually, it's a lot easier to do it the way we did it, where we don't have those unique IDs. Okay, but it violates the APIC style. And then I mentioned one other idea that you consider something called a multi-level bill of materials. And so if you think about it in case study 4, we introduced module X, module Y, and module Z, which were just unpainted versions of module A, module B, module C. So a module A is just a module X that you paint. Okay, and so the idea of a multi-level bill of material says we're going to define it that way, right? So our current approach, we have module A, which has 1 component 1, 2 component Bs, 4 component Cs, and then either red, blue, or green or yellow paint. And a module X is 1 component A, 2 component Bs, 4 component Cs. In a multi-level approach, our module X would be the exact same, but our module A would say, I need a module X and I need some paint. Okay, and so by multi-level, we're saying if you look at this in tree form, you know, it has multiple levels in the tree. You have module A, and it's going to have module X here, and so on. Okay, and then we discussed how this would impact our current models. Essentially, you'd have to have some way to generate orders or generate processing for module X. Because if I told you we have an order for our module A's, you have to somehow know that I need the components for module X. So you have to walk through, you have to do what's called a bill of materials explosion in your model to process all of those. So we didn't do any modeling with this, we just sort of talked about these 2 basic ideas. And then finally, there was an example model here that I said to have a look at if you're interested. This is scheduling bicycle assembly, where it does that. And so in this example, you have this create MOs and POs. MO stands for manufacturing order, and PO stands for purchase order. Okay, and so you purchase bicycles, those are the orders that you have. And if I purchase bicycles, I have to generate manufacturing orders for all of the components that go into that bicycle. So that's what this model demonstrates. Then lastly, we had our guest speaker, Garrett, talking about sort of the higher level incorporation, how we use Simio-RPS and simulation-based scheduling, where it fits into the enterprise and so on. And I'm not going to repeat his whole thing if you missed it, which thank you for coming, by the way. I'm pretty sure everybody came. I think I had one person missing, which was really awesome. He talked a lot about the sort of business cases here. A couple of the more interesting parts, or a couple of the important parts, was this notion of this 2-factory challenge, and said this is real in like every project I've ever done. You see this everywhere, right? Where you have this notion where corporate HQ or people who do high-level planning don't have a detailed understanding of what goes on at the lower level. So you have an idea of what factory capacity is, and you have an idea of what material availability is, and you have an idea about what the worker schedules and resource utilization and so on at the corporate level, and then you have reality at the factory level. So you have these 2 different visions of the same factory, right? And they clash, right? Because the higher level view doesn't really look at actual schedules and actual actionable schedules, but looks at design capacity. And design capacity, is not the same as actionable schedules. So you have this conflict between those 2. And so one of the things that the simulation-based planning and scheduling is designed for is so that we could bring the visibility that happens here up here. So rather than using things like rated throughputs or this general notion of design capacity, you can use actual capacity that is in response to actual either sales orders or purchase orders or production plans or however you're planning your production, so that you can use the detailed information so that you don't have this chasm between what one group thinks the factory should be able to do and what the other group knows the factory can actually do once it sees the specific plans. referred to this as this hidden factory or the two-factory challenge. And so then he talked about the Simio solution in simple terms, 5 simple steps. Yep.
The previous notion is a bit similar to the actionable plan and optimal plan.
What was that?
Actionable schedule and something like
Yeah, so actionable schedule. So this idea is when you look at design capacity, if I'm at the higher level and I'm trying to do a production plan, let's just say, for example, I have 5 plants in the United States and I'm trying to allocate production to those plants. So I have a notion of what my capacity is at each one, but when I'm actually allocating work, once I allocate work, well, then I have to deal with things like changeovers and that kind of stuff. And I have to deal with worker schedules and all of that. And so once you allocate actual work, then that has implications to the true capacity. Okay? And so if you have a tool that you can use to say, if you allocate this, here's what you will see, which is what the simulation-based scheduling is, then you can use that decisions here at the higher level to have a better view of the true capacity, that the true capacity being based on what you are actually going to make over whatever the planning horizon is. So you just have better visibility. So the 5 simple steps again, create a detailed factory model for design and analysis, connected to, generated from, and driven by your data. So you get data from the ERP system, generate your model, generate a schedule, write that schedule back to various production level systems and so on. While you're creating the schedule, you can evaluate risk. And by the way, this is one of the things that we didn't talk about much in class about this notion of risk evaluation, right? So that's the R when we talk about Simio RPS, risk-based planning and scheduling. We've only done the scheduling part. We never got to the actual risk part. What the risk part does is if you incorporate things like, let's say that you incorporate machine reliability. So I know machines are going to fail, but I don't know when they're going to fail. So I can't schedule a downtime, right? So I might run my machine for 2 weeks, and I suspect it might fail sometime during that 2 weeks, but I have no idea when. So you can't schedule it, but it's a risk to you. It's a risk to your schedule, right? So in risk-based mode, what you're doing is you're incorporating that randomness, and you're looking at the reliability and the probability of meeting a particular schedule, right? So if you look at a schedule that you have generated up there in box 3, you can see those little markers at the end, and those are the risk assessment for that schedule. So you're basically saying, if I generate this schedule, well, then I might have a breakdown at some point. And so if you replicate the model, incorporating that randomness, you can assess that risk. Okay, we didn't talk about that in this class. We didn't quite get that far, but it's there, and that's what they're talking about. Enabling factory execution. So we looked at this dispatch list, and the basic idea is when I generate a schedule, I'm giving the dispatch list to the various people. So you would generate a schedule for Abby Electronics, and you'd give the dispatch list to the kit. You give the dispatch list to assemble 1, assemble 2, assemble 3, or I guess we had 2 assembles. Assemble 1, assemble 2, finish 1, finish 2, finish 3, package, and each one has their own dispatch list, and so they are going to work to that list. Okay, and so that's the execution part. And then again, while you're doing all that, you're measuring performance through the metrics that are of interest to you. And so we have this digital continuum. You talk about one model. I think, let's see, is it one model, one truth? One model, one truth, one model, source of truth. I can't remember what the tagline is, but there is a tagline that they've gone back and forth of. The basic idea here is I'm going to use the same basic model to do design and analysis, traditional simulation, and planning and scheduling. So I use a model to design. I use that same model, or an extended version of that model to do planning and scheduling. And what that lets me do is continuous improvement, because I can do things like you're doing. So I have a model that I can use to schedule Abby Electronics. And now I'd like to say, let's see if we add a high-speed packager, what that will do. So we're taking a scheduling model, and then we're moving back into the simulation and analysis realm using the same model to say, what's going to happen? What's my best strategy here for expanding my facility? And then once you make the decision to do it, then you use that same model that you did for the simulation analysis or design and analysis to do planning and scheduling. Right? So that sort of one model, one source of truth thing is what is referred to as this digital continuum. And then lastly, this picture of the idea is that this is connected in an industry 4.0 context, is it's connected, and the model, the scheduling model, provides a central source of information, right? It uses information from the lower levels, like the execution system, any kind of automation, robotics, IoT devices that you have, right, to know where things are and what state they're in, so on. It then does planning, and then it writes the plan information back to higher level systems and mid-level systems to implementers. Say, here's the schedule that we're going to implement. Okay, and that's my review. Other than all of the semio details that we have done through our case studies, these are the basic topics that we've discussed.
I was wondering if you could post, was it possible to post a solution from the last exam?
No. But I did go over the solution. If you go back to look at the recorded lecture on whatever day that was, I answered every single question.
I have a question.
And, ordinarily I wouldn't care, but some of these problems, the exact wording is hard to do. And, if I were to scan my solution that I gave Grant, you couldn't read it anyway. So it wouldn't do you much good.
Okay.
But I will be more than happy to discuss any questions if you have. You go back and watch that video and you still have questions about any of the questions, ask on the discussion forum or to me by email or whatever. I'm happy to discuss them. Yeah.
We didn't implement this at multi-level below material. That's similar. I love it.
Is what now?
Below material multi-level.
Yeah, all of that stuff. Anything we've talked about is perfectly fair game.
And what will be the practical result of this? The compact model and
practical results of what now?
Practical results of we can do either we can do either way, right? We cannot use multi-level zero material, or we can use multi-level material in our schedule, right?
Yeah. I mean, if you look at Avi Electronics 4, I mean, there are 3 natural ways that we could do it. We could do it the way we did it, where you couldn't uniquely identify a module. You had to have module and color. You could use an APIC style, right? In which case I'm going to define unique SKUs and unique bills of material and unique routings for everything. Or you could use multi-level, right? So all 3 of those will work for the exact same model that we did. They're different implementations and they're different, implementation methodology.
Multi-level, I guess, we will have a more complex model, right? And then some computation.
Well, with a multi-level, you have to decide how to handle orders, these intermediate orders. So again, if I order module A, I have to somehow create module X's, right? And so you have to decide, am I going to keep an inventory of module X's? So maybe I have an inventory of module X's, and when I get an order for module A, I look at that inventory of module X's and say, okay, I'm going to pull 50 of those out, and then I'm going to paint them. And if those 50 aren't available, I'm going to produce them. Yeah. So 3 different ways to implement the same thing, and they all have different implications for how you do it. So it's not that one is particularly better than the other. It's just they're different. They're different ways. If I am consulting for a company that uses APIC style SKUs, I'm going to do the APIC style because I'm just going to read all the information indirectly, and I don't have to process it or do anything. If I'm working with a company that doesn't use APIC style SKUs, then I'm probably not going to use that because there's a lot of replicated information, and if they don't have that data, then I have to generate that data. So I'm probably not going to do that. I'm probably going to use the method that we use or the multi-level. Yep.
Just be sure, after case 25 and the tests were done, that we have anything during finals week to worry about?
You have nothing during finals week to worry about. Not a thing. As soon as you turn it in, you're done.
Student theory fair game for the second exam?
Is what? As much as I would love to say yes, because as grad students in IE, you should all know queuing theory, and I think queuing theory should be used on every single test in every single class, I'm not going to ask you any queuing theory questions. Anything else? Okay, as I said, not Thursday because I will be out of town, but I will answer discussion forum. And again, you are free to share anything that you'd like to share at this point. You cannot work together other than 2 of you. I said you could work together. By the way, I've gotten no emails from anyone. If you're working with someone, email me. I just need to know. You can work together. You can talk about it. You just can't all build models together. Okay? All right, see you guys.